So we're going to talk dividing polynomials. Basically, we're going to use synthetic division this time. But we're going to relate this synthetic division to our long division just so that you can see the difference. So if I was doing this function or this division problem, we would be taking x plus 5 and dividing it into 4x squared plus 23x minus 16. Okay, if we were doing synthetic division, we are going to take whatever would make this 0, so that would be negative 5, and we would be taking our coefficients with any placeholders that we need. So we would have 4, and then 23, and then negative 16. And so here's what we were doing before. We said first with first, and we said 4x. So then we took 4x all the way through, and we get 4x squared plus 20x, and we add the opposite. So this would be opposite, and this would be opposite. And so we would get 3x minus 16, and we would do first with first again, getting a 3, and then taking a 3 all the way through, getting 3x plus 15, but then adding the opposites, and then we would see that we got a negative 31 left over. So we would do minus 31 over x plus 5. Okay, so how does this relate to synthetic? Well, here's what we do with synthetic. So it says write k in the box. So k makes the divisor 0. So that's what I did right here is I wrote k in the box. And then I wrote the coefficients going all the way across like we were just talking about. And so the next thing that we are going to do is we're going to bring this guy down. And then we will multiply what's in the window towards what's under the line. So this would be negative 5 times 4, which is negative 20. And we would always add going down, which leaves us with 3. Then we would multiply negative 5 and 3 again, and we get negative 15. And then when we add going down, we got negative 31. So you can clearly see that we have the remainder 31. Negative 31. But what's really important is that you see that this guy, this depressed equation, is going to be 4x plus 3. Because here we have the constant, the x term, and the x squared term. So here we have the constant and the x term. We're just kind of growing it. Plus we have our remainder of 31, and we divide it by our divisor. So we can get the same exact answer. It's just that the synthetic division is a little bit easier, especially as we get bigger polynomials. So, by the way, let's go back here. We can see that x plus 5 was not a factor of 4x squared plus 23x minus 16 because it did not have a 0 for a remainder, right? Now, let's use synthetic division. The reason I'm getting those, I'm not getting them confused. It's basically the same thing, the same procedure. It's just what you put in the window is a little bit different. So if I want to find out if x minus 3 is a factor, I'm going to put a positive 3 in and see if I get a 0. So I take my coefficients, 1, and then 0, negative 4, and negative 15, and we would go bring this down. 3 times 1 is 3. Add going down is 3. 3 times 3 is 9. Add going down is 5. 5 times 3 is 15. Add going down is 0. So this one had a remainder of 0. So yes, x minus 3 is a factor of x cubed minus 4x minus 15. And you can also see that remaining factor, which is x squared plus 3x plus 5. So just so that you can be mindful of the fact that you are getting another factor when you get a 0. Okay, so let's talk the old way to substitute, because we're going to now relate synthetic division to synthetic substitution. So our old way to substitute would be putting a -4 everywhere that we had an x for f of -4. So this would be -4 to the 5th power minus 14 times -4. That's really ugly. -4 cubed minus 2 times -4 plus 5. So -4 to the 5th, if you have a calculator, is going to be -10 24. And then we're going to get a positive 896, and then a positive 8 and a positive 5. And so when we add all this up, and I literally just did this on the calculator, so we're going to get 115. Okay, so obviously if you have a calculator, it's not too bad. But if you don't have a calculator, that would be a bear. Okay, so let's see what it would look like synthetically. When we would put here, we would get, we would put -4 in. We're not putting the opposite because we're not looking at a factor. If we're looking at a factor, then we're going to put the opposite in to see if it would make 0, right? But this is just a value. And so we would put that in, and we would have 1, 0 for the x to the 4th, -14 for the x cubed, 0 for the x squared, -2 for the x, and then 5. And let's just actually move this over. All right, cool. All right, so we bring the 1 down. -4 times 1 is -4. Add going down, we get -4. -4 times -4 is 16. Add going down, it's 2. -4 times 2 is -8. Add going down, we get -8. -4 times -8 is 32. Add going down, we get 30. -4 times 30 is -120. And then add going down, we get -115. So we got the same thing. We got that f of -4 is -115. So if you don't have a calculator, synthetic's way easier. If you have a calculator, it doesn't really matter that much as long as you don't make mistakes putting it in. So synthetic substitution is really going to be your friend, and I really want you guys to start practicing that, okay? All right, have a good day.